Tsunamis are ocean-going shockwaves. They're one of the most destructive natural phenomena on Earth, causing massive loss of life and catastrophic damage to coastal communities. Although we often think of them as giant waves, their most dangerous aspect is actually what you can't see, not just because it's invisible, but because it makes the wave so much more powerful. In order for a tsunami to cause major damage, there needs to be a large displacement of water, which generates the wave. This can happen in the ocean or even on land. But if we're talking about really big waves, the ocean is where it's at. Undersea earthquakes are the most common cause of destructive tsunamis. When two tectonic plates that underlie the ocean floor suddenly slip past each other, the energy is released, creating a massive wave. The 2004 Indian Ocean tsunami, for example, was caused by an earthquake with a magnitude of 9.1 to 9.3 that occurred off the coast of Sumatra, Indonesia. The top of the wave was estimated to have been around 30 meters high as it headed toward the shore. But while we often imagine these waves crashing onto land, most of the largest tsunami waves don't actually make it to the coast. A study published in 2018 used data from the 2004 Indian Ocean tsunami to create a map of the wave heights along the coast of Thailand. And what they found was that the height of the wave didn't follow the shape of the land very closely. In some places, the wave went over 100 meters inland, but the wave height in those places was only about a meter high. Meanwhile, in some places where the water only receded a few meters from the shore, the wave was still around 10 meters high. That's because although the wave generated by the earthquake is what actually causes the tsunami, it's the way the wave interacts with the coastline that determines where the really dangerous water goes. As the wave approaches the coast, it slows down and the water recedes, exposing the seafloor. That creates a low spot that sucks up water like a vacuum cleaner. If the wave comes in at just the right angle, that water gets sloshed far inland. If it comes in at a bad angle, though, the wave will just kind of splash around and head back out to sea. So, what makes the worst tsunamis so deadly isn't the size of the initial wave, but rather the shape of the coastline and the seafloor, which determines how much water gets sucked up and sloshed around inshore. And that's why the deadliest tsunami waves often hit areas that are not directly in the path of the initial wave. Now, it turns out that you don't need an earthquake under the ocean to cause a damaging tsunami. In fact, similar waves can be generated on land as well. The 2011 Tohoku tsunami in Japan, for example, was triggered by an earthquake that happened on land. And some of the most damaging tsunamis in recorded history were caused by landslides that scientists think may have been triggered by earthquakes that happened on land. In 1498, a large landslide in Peru generated a wave that supposedly traveled all the way to Europe. And in 1587, a magnitude 8.2 earthquake in China triggered a tsunami that researchers believe may have affected Japan and the Philippines. Even volcanic eruptions can cause tsunamis. The 1815 eruption of Mount Tambora in Indonesia, which was the largest volcanic eruption in recorded history, generated a tsunami that killed thousands of people in Indonesia, Japan, China, and the Philippines. But when it comes to really big waves, it's undersea earthquakes that are the main event. Between 1900 and 2015, they caused 58% of all tsunamis that had a significant impact on human populations. The reason for this is probably related to the fact that most of the Earth's tectonic plates are at the bottom of the ocean. So underwater earthquakes are more common than ones that happen on land. Plus, the ocean gives the waves more room to build up before they hit the coast, making them even more dangerous. Knowing all of this, it's hard to say whether we could ever really prevent tsunami damage. But studying past events helps us understand the risks in different areas, and hopefully that will help us build safer structures and make better emergency plans so that fewer lives are lost in the future. Thanks for watching this episode, and thanks especially to our supporters who helped make it possible. You can learn more about our campaign and how you can get involved at our support page.